Hello students, welcome back to computer organization classes. So second module concepts, input and output organization. Let us see the single bus structure. So this is what the diagram we have seen earlier as well. So accessing IO devices. A single bus structure is the one where all the IO devices are connected through a common bus to the processor and memory. Right? Here two concepts comes to this single bus architecture, which deals with two ways, we can say, or two types of IO device also you can say. One is memory mapped IO and IO mapped IO. Memory mapped input output and input output mapped input output. Okay, IO mapped IO in short. So what is that memory mapped IO then? So in case of memory mapped IO, memory and input output devices share a common address line. That's it. So bus, you recall, there are three types of bus available: data bus, address bus and control bus. Data bus is the one where it is used to transfer the data from one peripheral to other peripheral. Address bus is the one, this is also used to transfer the data, but what type of data? Address information. Okay, special type of bus it is. It carries only the address information or location identity of the device. And the third one is the control bus. Control bus which transfers the control signals or control informations only. So in case of memory mapped IO, what happens is memory and IO devices which shares a common line or address space, common address space. So any data transfer function or instruction like move or load can be used to exchange the information, so between the memory and input output device. In case of IO mapped IO, what happens is memory and IO address spaces are different. So IO mapped IO is different from memory mapped IO. Very simple to understand. In case of memory mapped IO, the IO devices and memory locations which uses a common address space, whereas the address space are reserved or different for memory as well as memory location as well as for the IO devices in case of IO mapped IO. That is the only difference between memory mapped IO and IO mapped IO. Hope you are getting. Here you can see the diagram where bus is separated illustrated by considering three lines. One is called as address, other one is called as data, and the third one is called as control. So address bus will be communicating with the address decoder for analyzing or verification of the location identity. Then data lines will be communicated with the registers, various registers, okay, and hence to the input device connection you can see. And control lines, exchanging of information like indication. So certain indication bit, earlier we have seen, no, S in, S out and all in the previous session, just recall them. So such type of informations, right, they are considered as the control line. So they control informations and they pass through the control line. Okay. So here is the IO interface circuit diagram shown here. So processor which contains various registers and control register, general purpose register and control register, or you just mark it as processor. Okay, and keyboard and display. The updated diagram was what we have considered earlier, keyboard and display with one register, data in and data out. Data in with respect to keyboard and data out with respect to display. You can see the same here, data in and out register, simply it is marked as data. Apart from them, we have considered earlier as in bit with respect to keyboard, as out with respect to display. Now status and control it is marked as. So special registers are marked instead of a bit marking a single bit. Status register and control registers are marked inside the blocks of keyboard and display. So next is about the mechanisms used for interfacing the IO devices. So one is Program controlled IO. Processor repeatedly checks the status flag to achieve the required synchronization between the process and input output device. So this is must, because IO devices, like from a keyboard, whether a key is stroke, whether a keystroke is done, then obviously what will happen?